Question 1. For each statement below, indicate whether the answer is true or false. Statement 1. Experimentation is an iterative loop of running the flow on a sample dataset, evaluating performance, deciding whether to proceed, and potentially modifying the prompt or flow. The correct answer is true. Statement 2. Evaluation and refinement focuses solely on speed, not generalization to new data. The correct answer is false. Statement 3. You can return to experimentation from production if monitoring reveals issues. The correct answer is true. Statement 4. A flow is optional in prompt flow because prompts alone are sufficient for deployment. The correct answer is false. Now that we have gone through the questions and the correct answers, I'm going to explain why each one is correct. Let us connect the ideas step by step. For Statement 1, this is true because experimentation is a repeatable loop. You test with sample data, review results, then adjust prompts or the flow to improve outcomes. However, Statement 2 is false because evaluation is not just about speed. It also checks whether the solution still works on new or varied inputs. For example, a chatbot tested only on simple questions might fail when users ask longer or messier questions. Moreover, Statement 3 is true because production monitoring can reveal drift or errors. Therefore, you often go back to experimentation to tune prompts or update the flow. Consequently, Statement 4 is false because the flow is the core pipeline that connects steps like inputs, prompts, tools, and outputs. So prompts alone are not enough for a managed deployment. Question 2. Fill in the blanks by selecting the correct options from the drop-down menus. A deployed flow exposes an endpoint URL secured by an access key so other applications can integrate safely. Endpoint calls return results in near real time and can be used to deliver chat or agentic responses. Now that we have gone through the full question and the correct answers, I'm going to explain how these pieces fit together. Let us walk through the reasoning clearly. To begin with, a deployed flow must expose an endpoint URL because this is the address external applications use to send requests. Without an endpoint, there is no way to integrate the flow into real systems. At the same time, the access key is required for security, ensuring only authorized applications can call the endpoint, much like an API key used in production services. Next, the phrase "in near real time" is important because deployed flows are designed to respond immediately. For example, when a user sends a message to a chatbot and expects an instant reply. Finally, delivering chat or agentic responses reflects the actual use case of deployed flows. They are built to power conversational assistants or agent-style workflows, not offline exports or background batch jobs. Question 3. Fill in the blanks by selecting the correct options from the drop-down menus. In a RAG-enabled flow, the output of the index lookup tool, often the top-end results, is processed by a Python node to produce a single context string that includes contents and sources before sending the prompt to the LLM node. Now that we have gone through the full question and the correct answers, I am going to explain how this process works. Let us move through it step by step. To begin with, the index lookup tool returns the top-end results because retrieval usually brings back multiple relevant chunks rather than just one. Next, a Python node is used because those multiple results must be programmatically combined, cleaned, or formatted into a usable structure. As a result, this step produces a single context string, which is important because the language model expects one coherent block of context, not scattered fragments. Moreover, including both contents and sources, ensures the model has factual grounding. For example, a knowledge assistant can answer a question while also referencing where the information came from. Finally, this prepared context is sent to the LLM node, where the model uses it to generate an accurate and informed response, connecting retrieval and generation into one smooth workflow. Question 4. For each item, drag it to the correct, universally true definition or effect. Each item may be used once, more than once, or not at all. Message that defines the assistant's overarching behavior and constraints. System message, end user input or query, user message, model-generated reply to a user message, assistant response, line delimited file format where each line is a complete JSON object. JSON lines, weight set to 0 on an assistant message, ignored during training, weight set to 1 on an assistant message, included for training. Now that we have gone through all the items and their correct matches, I'm going to explain how each one fits into the training and messaging process. Let us walk through the logic clearly. To start, the system message defines global behavior, such as tone, rules, and boundaries, which guide the assistant across the entire conversation. Next, the user message represents what the end user actually asks, making it the primary input the model responds to. Following that, the assistant response is simply the model's generated output, produced in direct response to the user's message. Meanwhile, JSON lines is the correct file format, because each training example must be stored as a single JSON object on its own line, enabling efficient processing at scale. In addition, when a message has weight set to 0, it is ignored during training, meaning it does not influence parameter updates. Conversely, when the weight is set to 1, the message is included for training and actively contributes to how the model learns. As a result, these definitions ensure consistency, correctness, and reliability when preparing data for model training and evaluation. Question 5. Fill in the blanks by selecting the correct options from the drop-down menus. Within the map stage, teams first identify potential harms, then prioritize them by assessing likelihood and impact. Next, they test and verify whether the harms occur and under what conditions, and finally, document and share findings with stakeholders. Now that we have gone through the complete sentence and the correct answers, I'm going to explain how this process works. Let us move smoothly through each step. To begin with, teams identify potential harms because you cannot manage risks you have not clearly surfaced. For example, this might include biased outputs or unsafe recommendations. Next, they prioritize those harms using likelihood and impact, so high risk and high impact issues receive attention first. After that, teams test and verify, meaning they actively check when, how, and under what conditions those harms actually appear. Finally, they document and share the findings with stakeholders, ensuring transparency, accountability, and alignment across technical, legal, and business teams. Question 6. AI as a field has evolved over time. Which statement accurately reflects the history and definition of AI? Select one answer. AI has always had the same definition since its origin. B. AI definitions have shifted as technology and use cases evolved. C. AI was first introduced only with the rise of generative models. D. AI is defined only as computer vision and speech recognition. The correct answer is B. AI definitions have shifted as technology and use cases evolved. Now let us walk through the reasoning. AI has never been a static concept. Early definitions focused on symbolic reasoning and rule-based systems, where machines followed explicit instructions. As technology advanced, the field expanded to include machine learning, allowing systems to learn patterns from data rather than rely solely on rules. Moreover, recent breakthroughs in deep learning and generative models further broadened how AI is defined and understood, especially in areas like language generation and creative tasks. However, saying AI has always had the same definition is incorrect, because its meaning has changed alongside its capabilities. Likewise, AI did not begin with generative models. It existed decades earlier in expert systems and early pattern recognition. Finally, limiting AI only to computer vision and speech recognition is too narrow, since these are just specific applications within a much wider field. Thus, AI definitions have shifted as technology and use cases evolved, making option B the most accurate statement. Question 7. For each statement below, indicate whether the answer is true or false. Statement 1. The embedding dependency tells the SDK which embedding model deployment should vectorize the query text. The correct answer is true. Statement 2. A vector-based query can run without referencing an embedding model. The correct answer is false. Statement 3. That the embedding model deployment must be distinct from the chat model deployment. The correct answer is true. Statement 4. The embedding dependency parameter is only used for fine-tuning models. The correct answer is false. Now let us walk through the reasoning. To begin with, Statement 1 is true because the embedding dependency explicitly links the retriever to the embedding model, ensuring that text is converted into numeric vectors for comparison. However, Statement 2 is false because vector-based search depends entirely on embeddings. Without an embedding model, the system cannot create vectors to measure similarity. Statement 3 is true, since embedding models and chat models serve different purposes. One creates vectors, and while the other generates language, and they can be deployed separately. Finally, Statement 4 is false because embedding dependency has nothing to do with fine-tuning. Instead, it simply specifies which embedding model deployment is used for vectorization. Thus, understanding how embedding dependencies work is essential for building reliable vector-based retrieval and search workflows. Question 8. A product team is adding a generative chat feature. They have a list of possible harms: privacy leakage, toxic content, hallucinations. Next, they want evidence about how often these harms appear in realistic outputs before deciding on controls. What should they prioritize now? Select one answer. A. Perform measure activities that evaluate outputs against the harm definitions. B. Jump directly to mitigate by adding content filters without evaluation. C. Start manage by drafting an operational readiness plan. D. Revisit map to add business KPIs like conversion rate. The correct answer is A. Perform measure activities that evaluate outputs against the harm definitions. Now let us walk through the reasoning. After harms are identified, the next logical step is to measure them. This means testing real outputs against clear harm definitions to understand frequency and severity. Moreover, measuring provides evidence. For example, running prompts at scale can reveal how often hallucinations or toxic responses actually occur. However, jumping straight to mitigation skips this evidence, making controls less precise and potentially ineffective. Likewise, operational management comes later, after risks are measured and mitigations are designed. Finally, revisiting business KPIs does not address safety evidence, which is the immediate need at this stage. Thus, performing measure activities is the correct priority because it grounds future controls in real data and observed behavior. Question 9. Arrange the steps inside the map stage in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Step 1. Identify potential harms. Step 2. Prioritize identified harms. Step 3. Test and verify the prioritized harms. Step 4. Document and share the verified harms. Now let us walk through the reasoning. The process begins by identifying potential harms because teams must first surface all possible risks before taking action. Next, those harms are prioritized, typically based on likelihood and impact, so attention is focused on the most serious issues. After prioritization, teams test and verify the harms, confirming whether they actually occur and under what conditions. Finally, the verified harms are documented and shared, ensuring transparency, alignment, and enabling informed mitigation planning. Following this sequence ensures the map stage is systematic, evidence-based, and ready to support responsible decision-making. Question 10. When categorizing outputs by harm level during measurement, which two practices are essential? Select two answers. Define strict, objective criteria for each category before scoring. B. Change category definitions mid-run to speed up labeling. Use a clear taxonomy. D. Rely on evaluator intuition instead of written criteria. The correct answers are A and C. Define objective criteria for each category before scoring and use a clear taxonomy. Now let us walk through the reasoning. To begin with, defining strict and objective criteria is essential because it ensures every evaluator scores outputs the same way across time, teams, and data sets. Moreover, objective criteria make results reproducible, meaning future evaluations can be fairly compared to earlier measurements. In addition, using a clear taxonomy matters because harm categories must be well-structured, whether binary or multi-level, so evaluators clearly understand where each output belongs. However, changing definitions mid-run introduces inconsistency, which undermines the validity of the dataset and breaks baseline comparisons. Likewise, relying on intuition instead of written criteria leads to subjective judgments, making results unreliable and difficult to audit. Thus, defining strict criteria and using a clear taxonomy are the two essential practices for accurate and trustworthy harm measurement. Question 11. Your team is connecting directly with the Azure OpenAI SDK. Which two authentication methods are supported for this direct connection? Select two answers. Using a key, API key-based authentication. B. Using Microsoft Entra ID, token-based. C. Using a GitHub personal access token. D. Using SSH key pairs. The correct answers are A and B. Using a key, API key-based authentication, and using Microsoft Entra ID, token-based. Now let us walk through the reasoning. To begin with, API key-based authentication is supported because it provides a straightforward way for applications to securely authenticate directly with the Azure OpenAI SDK. Moreover, Microsoft Entra ID authentication is also supported, enabling token-based access, which is especially useful for enterprise scenarios requiring managed identities and centralized access control. However, GitHub personal access tokens are not designed for Azure OpenAI authentication, as they are specific to GitHub services. Likewise, SSH key pairs are used for secure shell access, not for authenticating API requests to the Azure OpenAI SDK. Thus, using an API key or Microsoft Entra ID are the two valid and supported authentication methods for direct connections. Question 12. You're tuning a summarization node in production. You want to try multiple prompts and connection settings, compare results, and pick the best one quickly. Which two choices align with this approach? Select two answers. A. Create variants of the LLM node to try different prompt content and connection settings. B. Use manual copy and paste between separate flows instead of variants for comparison. Leverage variant side-by-side comparisons to choose the most effective configuration. D. Switch to a Python tool. Variants are only available for Python nodes. The correct answers are A and C. Create variants of the LLM node to try different prompt content and connection settings, and leverage variant side-by-side comparisons to choose the most effective configuration. Now let us walk through the reasoning. To begin with, creating variants allows you to test multiple prompt formulations and connection settings within the same LLM node, making experimentation fast, controlled, and easy to track. Moreover, side-by-side comparisons let you evaluate outputs visually and objectively, so you can quickly see which variant produces clearer or more accurate summaries. However, manually copying and pasting between flows adds unnecessary overhead and makes comparisons harder to manage and reproduce. Likewise, switching to a Python tool is unnecessary because variants are designed specifically for LLM nodes, not Python nodes. Thus, using LLM node variants and comparing them side by side is the most efficient and reliable way to tune summarization behavior in production. Question 13. Which statements accurately describe the retrieval augmented generation RAG pattern? Select two answers. A. It retrieves grounding data relevant to the user's initial prompt. B. It reduces inference latency by skipping retrieval. C. It augments the prompt with retrieved context before generation. D. It eliminates the need for a language model. The correct answers are A and C. It retrieves grounding data relevant to the user's initial prompt, and it augments the prompt with retrieved context before generation. Now let us walk through the reasoning. To begin with, the RAG pattern always starts with retrieval, meaning the system first looks up grounding data that is relevant to the user's original prompt. This ensures the response is based on accurate and up-to-date information. Moreover, the retrieved content is then injected into the prompt, so the language model generates an answer using that additional context, resulting in more grounded and reliable outputs. However, RAG does not skip retrieval, so it does not reduce latency by avoiding that step. Retrieval is a core part of the pattern. Likewise, RAG does not remove the need for a language model. The model is still essential for generating the final response after the context is added. Thus, retrieving relevant grounding data and augmenting the prompt before generation are the two defining characteristics of the RAG pattern. Question 14. Fill in the blanks by selecting the correct options from the drop-down menus. The Azure AI Foundry Agent Service is delivered within Azure AI Foundry as a managed service to build and manage AI agents. The Copilot Studio environment allows users to extend Microsoft 365 Copilot capabilities or build agents for channels like Slack or Messenger. Now let us walk through the reasoning. To begin with, Azure AI Foundry Agent Service is designed as a fully managed service, which means Microsoft handles the underlying infrastructure while teams focus on building and operating AI agents. Moreover, this service runs inside Azure AI Foundry, providing a unified environment for managing models, tools, and agent workflows. In addition, Copilot Studio serves as a low-code environment, making it easy for users to extend existing copilots or design new agents without deep engineering effort. Finally, Microsoft 365 Copilot is the core platform being extended, allowing organizations to enhance productivity experiences or connect agents to external channels. Thus, these components work together to support scalable, manageable, and extensible AI agent development within the Microsoft ecosystem. So, question 15. For each statement below, indicate whether the answer is true or false. Statement 1. An IT help desk agent can troubleshoot common issues and escalate more complex problems. The correct answer is true. Statement 2. An IT help desk agent cannot track ticket statuses after escalation. The correct answer is false. Statement 3. An e-learning agent can recommend courses and track student progress in an LMS. The correct answer is true. Statement 4. An e-learning agent reduces student engagement because it limits course recommendations. The correct answer is false. Now let us walk through the reasoning. To begin with, Statement 1 is true because IT help desk agents are designed to handle first-level troubleshooting and escalate issues that require deeper technical support. However, Statement 2 is false. Since help desk integrations typically allow agents to continue tracking ticket status even after escalation to higher support tiers. Statement 3 is true because e-learning agents can integrate with learning management systems, recommend relevant courses, and monitor learner progress over time. Finally, Statement 4 is false because personalized recommendations actually increase engagement, helping students discover relevant content rather than limiting their options. Thus, these examples show how both IT help desk and e-learning agents enhance efficiency, visibility, and user engagement across their respective domains. Question 16. Fill in the blanks by selecting the correct options from the drop-down menus. Dynamic Tool Discovery allows an AI agent to query a centralized MCP server to fetch available tools at runtime, enabling access to the latest tool versions without modifying agent code. Now let us walk through the reasoning. To begin with, querying a centralized MCP server is essential because it acts as a live catalog of tools, rather than a fixed list baked into the agent. Moreover, fetching available tools at runtime means discovery happens while the agent is running, not only during development or deployment. As a result, the agent can automatically access the latest tool versions, ensuring updates and improvements are picked up immediately. Finally, this works without modifying agent code because changes are managed centrally, avoiding repeated code edits across multiple agents. Thus, Dynamic Tool Discovery enables flexibility, up-to-date integrations, and scalable tool management for AI agents. Question 17. For each Microsoft Agent Framework concept, drag it to the correct description in the correct match column. Each item may be used once, more than once, or not at all. Statement 1 provides abstractions for connecting to AI models from different providers. Chat clients. Statement 2 enables agents to extend functionality by invoking custom functions or built-in services. Tools and function integration. Statement 3 maintains conversation history and roles across multiple interactions. Conversation management. Statement 4 coordinates multiple agents to achieve shared goals. Agent orchestration. Now let us walk through the reasoning. To begin with, chat clients are responsible for abstracting connections to different AI providers, allowing the same agent logic to work with services like Azure OpenAI or other model platforms. Moreover, Tools and function integration enable agents to go beyond text generation, allowing them to call APIs, execute functions, and interact with external systems. In addition, conversation management handles context, roles, and message history, ensuring the agent remembers what has already happened across turns. Finally, agent orchestration coordinates multiple agents, enabling collaboration, task delegation, and shared goal achievement within complex workflows. Thus, each concept plays a distinct role, together forming the foundation of how the Microsoft Agent Framework supports scalable, extensible, and coordinated AI agents. Question 18. For each statement below, indicate whether it is true or false. Statement 1. Once agents are discovered, requests can be routed automatically to the correct skill. The correct answer is true. Statement 2. Responses in an A2A workflow are always returned in formats unsupported by the receiving agent. The correct answer is false. Statement 3. A routing agent can pass output from one agent as input to another to complete a workflow. The correct answer is true. Statement 4. A2A coordination requires all agents to be hosted on the same local machine. The correct answer is false. Now let us walk through the reasoning. To begin with, Statement 1 is true because agent discovery enables automatic routing, allowing requests to reach the agent or skill best suited to handle them. However, Statement 2 is false. Since A2A workflows exchange responses in supported formats, ensuring compatibility and smooth coordination between agents. Moreover, Statement 3 is true because routing agents manage data flow, chaining outputs from one agent into inputs for another to complete complex tasks. Finally, Statement 4 is false because A2A coordination supports distributed agents, which can run across different environments without requiring local hosting on the same machine. Thus, these statements together illustrate how agent discovery, routing, and coordination enable flexible and scalable multi-agent workflows. Question 19. In the context of extending an AI agent, what is a primary reason to add a custom tool rather than relying only on built-in capabilities? Select one answer. A. To prevent the agent from calling any external services or APIs. B. To let the agent execute domain-specific actions that a general AI model would struggle to handle alone. C. To guarantee zero errors across all tasks, regardless of data quality. D. To eliminate the need for any built-in tools. The correct answer is B. To let the agent execute domain-specific actions that a general AI model would struggle to handle alone. Now let us walk through the reasoning. General-purpose AI models are strong at understanding and generating language, but they often cannot perform specialized business logic or system operations on their own. By adding a custom tool, you encapsulate domain-specific logic, such as calling internal APIs, querying proprietary databases, or triggering workflows. Custom tools do not block external services. They usually enable access to them. Likewise, they cannot guarantee zero errors. And they do not replace built-in tools. Instead, they extend the agent's capabilities where generic models fall short. Thus, adding custom tools allows the agent to reliably perform specialized tasks that require structured actions beyond language generation. Question 20. A company designs a multi-agent system where the central orchestrator not only interprets user intent, but also ensures sub-agents coordinate properly to complete a task. Which responsibility is being exercised by the central agent? Select one answer. A. Debugging sub-agents individually. B. Managing collaboration across connected agents. C. executing each specialized task directly. D, bypassing the need for context forwarding. The correct answer is B, managing collaboration across connected agents. Now let us walk through the reasoning. In a multi-agent system, the central agent acts as the coordinator, making sure each sub-agent understands its role and how it fits into the overall task. Moreover, this orchestration responsibility involves routing requests, sharing context, and sequencing actions, so sub-agents work together rather than in isolation. However, the central agent does not debug sub-agents at runtime, and it does not execute every specialized task itself. Those responsibilities belong to the sub-agents. Likewise, context forwarding is not bypassed. It is actively managed by the central agent to ensure continuity and alignment across agents. Thus, managing collaboration across connected agents is the key responsibility demonstrated by the central orchestrator in this scenario. Question 21. Arrange the following steps in a unified orchestration workflow in the correct order. Instruction: drag and drop the items into the correct order, starting with the first step at the top. Step 1. Define your agents and their capabilities. Step 2. Select and create an orchestration pattern. Step 3. Configure callbacks or transforms. Step 4. Start a runtime to manage execution. Step 5. Invoke the orchestration with a task. Step 6. Retrieve results asynchronously. Now let us walk through the reasoning. The workflow begins by defining your agents and their capabilities, because the system must first understand what each agent can do and how they contribute to the overall solution. Next, an orchestration pattern is selected and created, such as sequential, parallel, or hierarchical, to control how agents collaborate. After that, callbacks or transforms are configured, allowing intermediate outputs to be handled, reshaped, or routed correctly between agents. Once the structure is in place, a runtime is started, which manages execution, communication, and agent lifecycles. Then, the orchestration is invoked with a task, triggering coordinated agent activity based on the defined pattern. Finally, results are retrieved asynchronously, enabling the system to continue operating while the orchestration completes in the background. Thus, this sequence ensures a structured, scalable, and efficient unified orchestration workflow. Question 22. A software company wants to automate its multi-agent content generation system. The workflow requires one agent to create blog titles, another to generate outlines, and a routing agent to coordinate the entire process by sending requests and responses among them. Select one answer. A. The workflow cannot be automated without human oversight. B. The company should use the agent-to-agent A2A protocol for coordination. C. Each agent must share the same physical server for communication. D. The routing agent must manually trigger every response exchange. The correct answer is B. The company should use the agent-to-agent A2A protocol for coordination. Now let us walk through the reasoning. In this scenario, multiple agents need to communicate, pass outputs, and coordinate tasks automatically. The agent-to-agent A2A protocol provides a standardized way for agents to discover each other, exchange messages, and route tasks without manual intervention. However, human oversight is not required for every step, since A2A supports automated workflows. Likewise, agents do not need to run on the same physical server. A2A is designed for distributed environments. Finally, routing does not require manual triggering of every exchange, because A2A handles communication and coordination automatically. Thus, using the A2A protocol is the correct and effective approach for automating this multi-agent content generation workflow. Question 23. A development team is integrating a chat client with an A2A agent server. They want users to receive real-time updates while the agent processes long tasks, such as generating detailed summaries. Which type of request should the client use? Select one answer. A. Non-streaming request. B. Streaming request. C. Batch request. D. Synchronous request. D. The correct answer is B. Streaming request. Now let us walk through the reasoning. When an agent performs long-running tasks, users benefit from seeing progress as it happens, rather than waiting for a single final response. A streaming request delivers incremental updates, allowing partial outputs to be sent as the agent continues processing. Moreover, this approach improves user experience because users can follow progress in real time, especially for tasks like summarization or analysis. However, a non-streaming request waits until the entire task is finished, which provides no visibility during execution. Likewise, batch requests are designed for grouping multiple jobs, not for live interaction. Finally, a synchronous request does not guarantee progressive updates, making it unsuitable for long-running agent workflows. Thus, a streaming request is the correct choice for delivering real-time updates during extended A2A agent processing. Question 24. You want to allow a team of developers to build agents in two different ways. Some prefer coding with an SDK, while others prefer a visual interface in a portal. Which service supports both approaches? Select one answer. A. B. Microsoft Agent Framework. C. Azure AI Foundry Agent Service. D. OpenAI Assistance API. The correct answer is C. Azure AI Foundry Agent Service. Now let us walk through the reasoning. Azure AI Foundry Agent Service is designed to support both developer preferences, offering a visual design experience through the Azure portal, alongside a code-first experience using an SDK. This flexibility allows teams to collaborate effectively, enabling visual builders to configure agents quickly, while developers can implement advanced logic programmatically. However, AutoGen is an open-source and experimental framework, not integrated into a managed portal experience. Likewise, Microsoft Agent Framework is a lightweight framework focused on orchestration and code without a dedicated visual design portal. Finally, the OpenAI Assistance API is primarily code-first and does not provide a native visual interface for agent design. Thus, Azure AI Foundry Agent Service is the correct choice because it supports both SDK-based development and visual agent creation in a unified platform. Question 25. Which two benefits describe the advantages of multi-agent orchestration over single-agent systems? Select two answers. Assign distinct skills and responsibilities to different agents. B. Limit each agent to identical instructions for simplicity. C. Combine multiple agents' outputs to improve accuracy. D. Restrict workflow control to a single agent. The correct answers are A and C. Assign distinct skills and responsibilities to different agents and combine multiple agents' outputs to improve accuracy. Now let us walk through the reasoning. Multi-agent orchestration allows each agent to specialize. For example, one agent can focus on research, another on reasoning, and another on validation, which improves overall performance and flexibility. Moreover, combining outputs from multiple agents increases accuracy because results can be cross-checked, refined, or enriched through collaboration, reducing errors from a single point of failure. However, Giving all agents identical instructions removes the benefit of specialization, which is a core strength of multi-agent systems. Likewise, restricting workflow control to a single agent contradicts orchestration, which is designed to distribute responsibilities and coordinate agents dynamically. Thus, assigning specialized roles and combining agent outputs are the key advantages that make multi-agent orchestration more powerful than single-agent systems. Question 26. Which statement accurately describes how agents behave in group chat orchestration? Select one answer. A. Agents automatically deploy code changes based on conversation results. B. Agents primarily contribute to discussion rather than directly modifying systems. C. Each agent executes commands in a shared runtime environment. D. Agents always perform system updates after each message. The correct answer is B. Agents primarily contribute to discussion rather than directly modifying systems. Now let us walk through the reasoning. In group chat orchestration, agents are designed to collaborate through conversation, sharing ideas, reasoning, and suggestions rather than taking direct system actions. Moreover, this pattern emphasizes discussion and coordination, allowing agents to collectively analyze problems or propose solutions, much like participants in a group chat. However, agents do not automatically deploy code, execute commands, or perform system updates in this orchestration model. Those actions belong to other execution or tool-based patterns. Thus, the defining behavior of group chat orchestration is that agents primarily contribute to discussion, making option B the correct and accurate description. Question 27. When defining an agent skill, why is it important to include clear descriptions and examples? Select one answer. A. It allows other agents and clients to understand and properly use the skill. B. It helps the agent run faster during execution. C. It hides the skill's complexity from routing agents. It prevents unauthorized access to the agent. The correct answer is A. It allows other agents and clients to understand and properly use the skill. Now let us walk through the reasoning. Agent skills are meant to be discovered, invoked, and reused by other agents or client applications. Clear descriptions explain what the skill does, while examples show how and when it should be used. Moreover, this clarity helps routing agents choose the right skill for a given task, ensuring requests are sent to the most appropriate capability. However, detailed descriptions do not make the agent execute faster. Performance depends on implementation, not documentation. Likewise, descriptions do not hide complexity or control access. Those concerns are handled through orchestration logic and authentication settings. Thus, providing clear descriptions and examples ensures agent skills are understandable, discoverable, and correctly used across multi-agent systems. Question 28. For each feature comparison point, drag the correct characteristic of question answering or language understanding into the correct match column. Each item may be used once, more than once, or not at all. Statement 1. User submits a question, expecting an answer. Question answering. Statement 2. Service interprets utterance to determine intent and entities. Language understanding. Statement 3. Response is a static answer to a known question. Question answering. Statement 4. Client application performs action based on detected intent. Language understanding. Now, let us walk through the reasoning. Question answering fits statements where the user asks a direct question and expects an answer, because the system searches a knowledge source and returns a predefined response. Therefore, A static answer to a known question belongs to question answering. Moreover, language understanding focuses on interpreting what the user wants to do by identifying intent and extracting entities. Consequently, the client app can take an action based on that detected intent, like opening a support ticket when the intent is report issue, or booking a meeting when the intent is schedule meeting. However, question answering does not primarily trigger actions. It returns answers. And language understanding does not rely on a fixed answer list. It drives behavior based on intents and entities. Question answering maps to question and static response scenarios, while language understanding maps to intent detection and action execution scenarios. Question 29. For each statement below, indicate whether it is true or false. Statement 1. Developers can use REST APIs or SDKs to create a question-answering knowledge base. The correct answer is true. Statement 2. Using the Language Studio interface is the most common method for defining a knowledge base. The correct answer is true. Statement 3. An Azure AI search resource is optional when creating a knowledge base. The correct answer is false. Statement 4. Chit-chat datasets are used to add predefined conversational exchanges. The correct answer is true. Now let us walk through the reasoning. To begin with, Statement 1 is true because REST APIs and SDKs allow developers to programmatically create, update, and manage question-answering knowledge bases. Moreover, Statement 2 is true, since Language Studio provides a visual, no-code environment, making it the most common and accessible way to define and manage knowledge bases. However, Statement 3 is false, because an Azure AI search resource is required. It hosts the index that stores and retrieves the knowledge base content. Finally, Statement 4 is true because chit-chat datasets add predefined conversational responses, helping the system handle casual or common user interactions more naturally. Thus, these statements together explain how question-answering knowledge bases are created, managed, and enhanced for better user experience. Question 30. Match each concept with its correct description. Each item may be used once, more than once, or not at all. Statement 1 helps improve accuracy of responses by analyzing alternate ways users ask similar questions. Active learning. Statement 2 allows a question-answering service to recognize equivalent words with similar meanings. Synonyms. Statement 3 provides suggested alternate questions for each question-answer pair. Active learning. Statement 4 uses JSON format through REST API to configure meaning-equivalent terms. Synonyms. Now let us walk through the reasoning. Active learning focuses on improving the system over time by analyzing how users phrase questions differently and then suggesting alternate question variations. This helps the knowledge base better match real user queries. Moreover, by providing suggested alternate questions, active learning allows authors to continuously refine and expand question coverage, increasing accuracy and relevance. On the other hand, synonyms handle language variation by mapping different words that share the same meaning. So the system returns the correct answer even when users use different terminology. Additionally, synonyms can be defined programmatically using JSON through REST APIs, making it easy to manage meaning-equivalent terms at scale. Thus, active learning improves understanding through usage patterns, while synonyms improve recognition through vocabulary alignment, together strengthening the overall question-answering experience. Question 31. Fill in the blanks by selecting the correct options from the drop-down menus. To use a custom translation model, specify its category ID in the category parameter when calling the Azure AI Translator API. Now let us walk through the reasoning. A custom translation model is created using Custom Translator, and each custom model is identified by a unique category ID. Therefore, when you want the translator API to use that specific custom model, you must explicitly pass the category ID so the service knows which model to apply. Moreover, the category parameter in the API request is the mechanism that routes the translation request to the correct custom model. However, workspace names or project names are used only for organization in the portal, not for selecting models during API calls. Likewise, token or alignment parameters are unrelated to choosing a custom translation model. Thus, providing the category ID in the category parameter is the correct and required way to invoke a custom translation model using the Azure AI Translator API. Question 32. Fill in the blanks by selecting the correct options from the drop-down menus. In Azure AI Foundry, multimodal models can process both text and audio inputs, enabling chat applications to understand spoken prompts. Now let us walk through the reasoning. Multimodal models are specifically designed to handle more than one type of input, instead of being limited to text alone. Because of this, they can process text inputs, such as typed questions, as well as audio inputs, such as spoken prompts. Moreover, this capability allows chat applications to support voice-based interactions, where users speak instead of type, while the model still understands and responds correctly. However, text-only models cannot handle audio hookups, which makes them unsuitable for voice-enabled chat scenarios. Thus, multimodal models processing both text and audio inputs is what enables modern chat applications to understand and respond to spoken prompts. Question 33. A developer is building a question-answering solution in Azure. They want to quickly define and publish the knowledge base without writing any code. Which approach should they take? Select one answer, A. Build the knowledge base entirely through REST API calls. B. Use the Language Studio web interface. C. Create a virtual machine and install the SDK manually. D. Store the knowledge base in a SQL database. The correct answer is B. Use the Language Studio web interface. Now let us walk through the reasoning. Language Studio provides a visual, no-code environment that allows developers to create, manage, train, and publish a question-answering knowledge base quickly. Moreover, it is designed specifically for ease of use, making it the most efficient choice when speed and simplicity are the priority. However, using REST APIs requires writing code, which does not meet the requirement of avoiding development work. Likewise, creating a virtual machine and installing an SDK adds unnecessary complexity and is not required for building a knowledge base. Finally, storing the knowledge base in a SQL database is not how question answering works, since the service relies on Azure AI Search for indexing and retrieval. Thus, using the Language Studio web interface is the correct and most practical approach for quickly publishing a question-answering solution without writing code. Question 34. A developer wants to upload a large set of existing question and answer pairs into a new knowledge base instead of entering them manually. Which option should they choose? Select one answer. A. Manually add each question through the portal. B. Import a file containing question and answer pairs. C. Enable translation to detect duplicates. D. Submit the data through Azure Monitor. The correct answer is B. import a file containing question and answer pairs. Now let us walk through the reasoning. When working with a large volume of existing content, manually adding each question would be slow, repetitive, and inefficient. Importing a file allows developers to bulk upload structured question and answer pairs, significantly speeding up the creation of the knowledge base. Moreover, this approach is designed specifically for reuse of existing datasets, making it ideal when content already exists in documents or files. However, translation features are unrelated to importing data, and Azure Monitor is used for monitoring, not content ingestion. Thus, importing a file containing question and answer pairs is the most efficient and appropriate choice for populating a new knowledge base at scale. Question 35. For each statement below, indicate whether it is true or false. Statement 1. The Azure AI Language Service uses endpoints prefixed with the resource created in your Azure account. The correct answer is true. Statement 2. Custom named entity recognition requires no training data. The correct answer is false. Statement 3. Sentiment analysis determines whether text expresses positive, negative, or neutral emotions. The correct answer is true. Statement 4. PII detection cannot identify IP addresses. The correct answer is false. Now let us walk through the reasoning. To begin with, Statement 1 is true because Azure AI language endpoints are generated based on the specific Azure resource you create, and all API calls are routed through that resource endpoint. However, Statement 2 is false, since custom named entity recognition requires labeled training data, so the model can learn to recognize user-defined entities accurately. Moreover, Statement 3 is true, because sentiment analysis evaluates emotional polarity, classifying text as positive, negative, or neutral based on language cues. Finally, Statement 4 is false, because PII detection is capable of identifying sensitive information, including IP addresses, email addresses, and other personal data. Thus, these statements highlight how Azure AI language services handle endpoints, training requirements, sentiment analysis, and sensitive data detection. Question 36. For each statement below, indicate whether the answer is true or false. Statement 1. The detect response can include language, yeah, and a score such as 1.0. The correct answer is true. Statement 2. The translate endpoint supports multiple parameters in a single request. The correct answer is true. Statement 3. Transliteration changes the meaning of text from Japanese to English. The correct answer is false. Statement 4. Using from script JPAN and to script equals Latin renders Japanese text in Latin script. The correct answer is true. Now let us walk through the reasoning. To begin with, Statement 1 is true because the detect endpoint returns both the detected language code, such as Ja for Japanese, and a confidence score indicating certainty. Moreover, Statement 2 is true, since the translate endpoint allows multiple parameters, enabling one source text to be translated into several target languages within a single request. However, Statement 3 is false, because transliteration does not translate meaning. It only converts text from one writing system to another, preserving pronunciation rather than semantics. Finally, Statement 4 is true, because specifying from script JPAN and to script equals Latin converts Japanese characters into their Latin alphabet representation, such as rendering Japanese words in Romanized form. Thus, these statements clarify how language detection, translation, and transliteration behave within the Azure AI Translator service. Question 37. Arrange the following steps to provision and use an Azure AI speech resource in the correct order. Instruction. Drag and drop the items into the correct order, starting with the first step at the top. Step 1. Create a speech resource in an Azure subscription. Step 2. Retrieve the resource key and location from the Azure portal. Step 3. Install the Azure Speech SDK. Step 4. Instantiate a speech config object with the key and region. Step 5. Use the configured SDK to call speech APIs. Now let us walk through the reasoning. The process begins by creating a speech resource, because this is what provisions access to the Azure AI speech service. Next, the resource key and region are retrieved from the Azure portal, as these credentials are required for authentication. After that, the Azure Speech SDK is installed, enabling developers to interact with the service programmatically. Once the SDK is available, a speech config object is instantiated, using the key and region to establish the connection. Finally, the configured SDK is used to call speech APIs, allowing applications to perform speech recognition, synthesis, or translation tasks. Thus, following this sequence ensures the speech service is correctly provisioned, configured, and ready for use in applications. Question 38. What happens when a conversational app uses Azure AI language question answering? Select one answer. A. The app relies on static responses stored locally instead of querying the cloud. B. The knowledge base stores responses but cannot be accessed by apps. C. The app sends queries directly to the REST endpoint of the knowledge base and receives matching answers. D. The app must download the entire knowledge base before responding to questions. The correct answer is C. The app sends queries directly to the REST endpoint of the knowledge base and receives matching answers. Now let us walk through the reasoning. To begin with, Azure AI language question answering is a cloud-based service designed to be accessed programmatically by applications, rather than through local storage. Therefore, when a user asks a question in a conversational app, the app sends that query to the question answering REST endpoint, which searches the hosted knowledge base. As a result, the service returns the most relevant matching answer in real time, without requiring the app to store or manage the knowledge base locally. However, relying on static local responses would defeat the purpose of a centrally managed and continuously updated knowledge base, making option A incorrect. Likewise, option B is incorrect, because the knowledge base is explicitly designed to be accessed by applications through APIs. Finally, option D is incorrect, since downloading the entire knowledge base is unnecessary. All interactions occur through lightweight REST API calls. Thus, sending queries directly to the REST endpoint and receiving matching answers is the correct description of how conversational apps use Azure AI language question answering. Question 39. In a travel-related knowledge base, a question about canceling reservations may produce an answer that says, cancellation policies depend on the type of reservation, followed by options to cancel a flight or hotel. What feature enables these linked follow-up options within the same answer? Select one answer. A. Automatic translation of responses. B. Multi-turn conversation using follow-up prompts. C. Standalone single-turn responses. D. User intent detection through language understanding. The correct answer is B. Multi-turn conversation using follow-up prompts. Now let us walk through the reasoning. To start with, multi-turn conversation support allows a single answer to guide the user through additional related choices, rather than ending the interaction after one response. Therefore, When the knowledge base explains that cancellation policies vary, it can immediately present follow-up options, such as canceling a flight or canceling a hotel. As a result, the user remains within the same conversational flow, selecting the option that best matches their situation, without needing to rephrase or ask a new question. However, automatic translation only converts text between languages. It does not introduce branching or linked follow-up options, making option A incorrect. Likewise, standalone single-turn responses provide only one static answer, with no opportunity for clarification or continuation. So option C does not apply. Finally, language understanding focuses on detecting intent and entities, not on structuring linked conversational answers within a knowledge base, which rules out option D. Thus, multi-turn conversation using follow-up prompts is the feature that enables linked follow-up options within the same answer. Question 40. What response header provides the URL to check the status of a deployment job? Select one answer. A, operation location, location, B, C, status URL, D, job reference. The correct answer is A, operation location. Now let us walk through the reasoning. To begin with, many Azure AI and REST-based operations are asynchronous, meaning the job does not complete immediately after submission. Therefore, when a deployment request is submitted, the service responds with an operation location header, which contains a URL pointing to the job status endpoint. As a result, the client can poll this URL to check whether the deployment is still running, has succeeded, or has failed. However, the location header is typically used for redirection purposes, not for tracking asynchronous job status, which makes option B incorrect. Likewise, status URL is not a standard or supported response header in Azure REST APIs, so option C is invalid. Finally, job reference may sound descriptive, but it is not an actual response header used by Azure services, ruling out option D. Thus, the operation location header is the correct and reliable way to obtain the URL for checking the status of a deployment job. Question 41. Annotators sometimes miss instances of a target entity because they rush through long documents. Which practice directly addresses this problem? Select one answer. A, convert all documents to a single template to reduce scanning effort. B, ensure completeness by labeling all occurrences of the target entity in each file. C, increase the region length for every document to cover more text. D, focus only on entities that are easy to spot. The correct answer is B, ensure completeness by labeling all occurrences of the target entity in each file. Now let us walk through the reasoning. To begin with, the core issue described here is missed annotations, caused by rushing through long documents. Therefore, the most effective corrective practice is to emphasize completeness, making sure every occurrence of the target entity is labeled, not just the most obvious ones. As a result, the model learns consistent and reliable patterns, improving recall and reducing the risk of missing entities during inference. However, converting documents into a single template may improve readability, but it does not guarantee that annotators will label every instance, which makes option A insufficient. Likewise, increasing region length only exposes more text at once. It does not ensure careful or complete labeling, so option C does not solve the root problem. Finally, focusing only on easy-to-spot entities introduces bias, weakens training quality, and directly harms the model's ability to generalize, ruling out option D. Thus, ensuring completeness by labeling all occurrences of the target entity in each file is the correct and most effective practice. Question 42. A software company is creating a mobile app that can instantly translate customer voice input from Spanish to English and French. They want to integrate this using Azure. What should they ensure before they start development? Select two answers. A. Create an Azure AI speech or Azure AI services resource in their subscription. B. Create separate Azure subscriptions for each language translation. C. Install a speech recognition only SDK. Obtain one of the keys and the location of the resource from the Azure portal. The correct answers are A and D. Create an Azure AI speech or Azure AI services resource in their subscription. And obtain one of the keys and the location of the resource from the Azure portal. Now, let us walk through the reasoning. To begin with, Azure speech translation capabilities require an Azure resource to be provisioned so that the service can authenticate requests and provide access to speech and translation features. Therefore, creating an Azure AI speech or Azure AI services resource is the first essential step. Without it, the application has nothing to connect to. In addition, every Azure AI resource provides access keys and a region or location, which are required by client applications and SDKs to authenticate and route requests correctly. As a result, obtaining the resource key and location from the Azure portal is equally critical before development can begin. However, creating separate Azure subscriptions for each language is unnecessary. Since a single resource can support multiple source and target languages, likewise, installing a speech recognition only SDK is insufficient because speech translation requires translation-enabled APIs rather than recognition alone. Thus, ensuring the Azure AI speech or Azure AI services resource exists. And retrieving its key and location are the two correct prerequisites before starting development. Question 43. When using named entity recognition, which two statements are true? Select two answers. Entities are categorized into groups such as person, location, and date time. B. Each entity includes a confidence score between 0 and 1. C. Entities must appear only once per document. D. The request input can include multiple documents. The correct answers are A and B. Now let us walk through the reasoning. Named entity recognition is designed to identify and classify key elements in text. Therefore, entities such as names of people, places, and dates are automatically grouped into predefined categories, like person, location, and date time. This is why option A is correct. In addition, the service assigns a confidence score to each detected entity. This score ranges between 0 and 1 and indicates how confident the model is in its prediction. Consequently, option B is also correct. However, option C is incorrect because the same entity can appear multiple times within a single document and each occurrence can be recognized independently. Likewise, option D is not considered correct in this context. Even though the API can process multiple documents in one request, the statement does not describe a defining property of named entities themselves. Let us relate this to real usage. When analyzing a paragraph that mentions London several times along with multiple dates, the model categorizes each mention correctly and assigns confidence scores to every entity it detects. Thus, the two true statements for question 43 are: entities are categorized into groups such as person, location, and date time, and each entity includes a confidence score between 0 and 1. Question 44. Which two statements accurately describe entity linking? Select two answers. A. It connects identified entities in text to external knowledge base articles. B. It uses Wikipedia as the knowledge base for disambiguation. C. It requires manual tagging of each entity before processing. D. It provides only sentiment scores for entities. The correct answers are A and B. It connects identified entities in text to external knowledge base articles. And it uses Wikipedia as the knowledge base for disambiguation. Now let us walk through the reasoning. To begin with, entity linking is designed to go beyond simply detecting entity names in text. Its main purpose is to identify which real-world entity is being referenced. Therefore, when an entity such as Paris or Microsoft appears, the service links it to a corresponding external knowledge base article, clarifying exactly which entity is intended. In addition, Azure AI Language uses Wikipedia as its primary knowledge source for this disambiguation, ensuring consistent and widely recognized references. As a result, entity linking can distinguish between entities that share the same name, such as Paris, the city, versus Paris, the person. However, manual tagging is not required. The model performs entity detection and linking automatically, which makes option C incorrect. Likewise, sentiment scores are produced by sentiment analysis, not by entity linking. So option D does not apply. Thus, connecting identified entities to external knowledge base articles and using Wikipedia for disambiguation are the two statements that accurately describe entity linking. Question 45. Which set of properties can be found in a speech recognition result object returned by the speech-to-text API? Select three answers. A. Duration. B. Offset in ticks. C. Result ID. D. Audio length. The correct answers are A. Duration. B. Offset in ticks. Result ID. Now let us walk through the reasoning. To begin with, the speech recognition result object is designed to provide detailed metadata about each recognized speech segment. Therefore, the duration property indicates how long the recognized portion of audio lasted, which helps align text with audio timing. In addition, offset in ticks specifies where the recognized speech begins within the input audio stream, making it useful for synchronization and analysis. Furthermore, Result ID provides a unique identifier for each recognition result, allowing developers to track or reference individual results reliably. However, audio length is not included in the speech recognition result object because the API focuses on recognized segments rather than the full input audio length. Thus, duration, offset in ticks, and result ID are the correct properties returned in a speech recognition result object. Question 46. Fill in the blanks by selecting the correct options from the drop-down menus. Digital asset platforms often rely on smart crop thumbnails to keep the subject centered, a feature provided by Azure AI Vision. For automated image workflows, the correct answers are smart cropped thumbnails and Azure AI Vision. Now let us walk through the reasoning. To begin with, digital asset platforms frequently need consistent and visually appealing thumbnails across different screen sizes and layouts. Therefore, smart cropped thumbnails are used to automatically focus on the most important part of an image, ensuring the main subject stays centered, even when aspect ratios change. Moreover, Azure AI Vision provides this smart crop capability by analyzing the image content, identifying areas of interest, and generating thumbnails that preserve visual meaning. As a result, organizations can automate large-scale image workflows without manually editing or cropping each asset. However, services like document intelligence or custom analyzers focus on structured data extracting, not intelligent image cropping, which makes them unsuitable for this use case. Thus, relying on smart crop thumbnails, powered by Azure AI Vision, is the correct and effective approach for automated image workflows in digital asset platforms. This sum Question 47. For each statement below, indicate whether the answer is true or false. A recognition model trained in one Face API resource can be reused in another Azure resource automatically. False. The find similar operation can rank multiple candidates based on resemblance scores. True. When a Face ID expires, verification and comparison using that ID will fail. True. Person groups are required for both verification and similarity operations. False. Now let us walk through the reasoning. To begin with, Face API models and trained data are scoped to the Azure resource where they are created. Therefore, a recognition model cannot be automatically reused across different Azure resources, which makes the first statement false. Next, the find similar operation is specifically designed to compare a detected face against multiple candidates and then rank those candidates using resemblance or confidence scores, making the second statement true. Moving forward, Face IDs are temporary identifiers. Once they expire, any verification or comparison attempt using that ID will no longer work, which confirms the third statement as true. Finally, while person groups are commonly used, they are not strictly required for all verification or similarity scenarios, since temporary Face IDs can also be used, making the last statement false. Thus, these true and false determinations accurately reflect how Face API recognition, similarity, and verification behave in practice. Question 48. For each description, drag the correct concept name into the correct match column. Each item may be used once, more than once, or not at all. Interactive environment in Azure AI Foundry used to test prompts that include images, chat playground, portal area for browsing available foundation models and curated sets, model catalog and collections, example of a Microsoft model designed for multimodal instruction following Microsoft 5.4 Multimodal Instruct, OpenAI Foundation model designed for multimodal input, OpenAI GPT-4o, cost-optimized OpenAI Multimodal Foundation Model, OpenAI GPT-4o-Mini. Now let us walk through the reasoning. Chat Playground is the interactive testing surface, where you can try prompts that include images and review model responses. Moreover, Model Catalog and Collections is the browsing hub, where you discover available foundation models and curated sets. Next, Microsoft 5.4 Multimodal Instruct is a Microsoft model built for multimodal instruction following, especially when visual input is involved. In addition, OpenAI GPT-4o is an OpenAI multimodal foundation model capable of handling text plus visual input. Finally, OpenAI GPT-4o Mini is the cost-optimized multimodal option designed for vision plus text use cases at lower cost. Question 49. A developer is designing a chat system where each participant's message must specify who sent it and what content it includes, such as text or images. Which JSON structure correctly represents this relationship? Select one answer. The messages array contains message objects, and each message has a role and a content field. Correct? B. Each content item contains an array of messages with multiple roles. C. Wrong. The role field stores both text and image data together. Wrong. D. The JSON structure does not include a messages array. Content is stored as plain text. Wrong. Now that we have gone through all the answer choices and clearly identified the correct answer, let me explain how this works. To begin with, chat-based systems are built around structured message exchanges. Each interaction is stored as a message object, which clearly defines who sent the message using the role field, such as user, assistant, or system. At the same time, the content field holds what was actually sent, whether that is text, images, or other supported input types. This separation keeps responsibilities clear and makes conversations easy to process programmatically. By contrast, content does not contain messages. Messages contain content. So reversing that structure would break the logical flow of a conversation. Similarly, the role field is only an identifier. It never stores text or image data itself. That information always belongs in the content field. Finally, a proper chat structure always includes a messages array. Without it, there would be no organized way to represent a multi-turn conversation. So, the correct answer is that the messages array contains message objects, and each message has a role in a content field. Question 50. For each statement below, indicate whether the answer is true or false. The images playground enables direct experimentation with DALL-E model parameters. True, all generated images in the playground must be 1024x1024 pixels. False, changing resolution to 1792x1024 creates a wider image compared to 1024x1024. True. Adjusting image style from vivid to natural changes brightness rather than overall look. Now that we have gone through all the statements and their correct answers, let me walk you through the explanation. To start with, the images playground is designed specifically for hands-on experimentation, allowing users to adjust parameters like size and style before deploying image generation into an application. On the other hand, it is not true that all images must be 1024 by 1024 because the playground supports multiple resolutions, including landscape and portrait formats. As we move forward, selecting 1792 by 1024 clearly produces a wider landscape-style image when compared to a square 1024 by 1024 output. Finally, changing the image style from vivid to natural does more than affect brightness. It influences the overall artistic tone, color balance, and visual realism, which is why that statement is false. Question 51. A transit security team must detect very small faces in crowded scenes. They can accept fewer facial attribute outputs if it improves detection accuracy on small faces. What is the best approach? Select one answer. A. Choose an older recognition model to maximize attribute variety. B. Choose a newer face detection model version optimized for small faces. Accepting a reduced attribute set. C. Use only facial landmarks. Landmarks improve small face detection automatically. D. Rely on quality for recognition alone. It increases detection accuracy on small faces. The correct answer is B. Choose a newer face detection model version optimized for small faces. Accepting a reduced attribute set. Now that we have gone through the full question and every answer choice, let's walk through why B is the best fit. To begin with, the core requirement is detecting very small faces in crowded scenes. So the priority is detection performance, not maximizing extra attributes. Therefore, choosing a newer face detection model optimized for small faces directly targets the main problem. And accepting fewer attribute outputs is a reasonable trade-off when accuracy matters most. However, Option A focuses on recognition and attribute variety, and that does not improve the initial step of detecting tiny faces in the first place. Likewise, Option C is misleading because landmarks are typically returned after detection. So they cannot replace a strong detection model or automatically improve detection on small faces. Finally, Option D does not solve the detection challenge because quality for recognition is a quality score for suitability. It does not upgrade the detection model's ability to find small faces. Thus, selecting a newer face detection model optimized for small faces, even with fewer attributes, is the most effective approach for this scenario. Question 52. Which statement best describes data retention in responsible face-based AI solutions? Select one answer. A. Facial data should be archived indefinitely for future use. B. Retention policies are unnecessary if encryption is used. Facial data should be kept only as long as needed for its stated purpose. D. Short-term storage is optional if data is anonymized. The correct answer is C. Facial data should be kept only as long as needed for its stated purpose. Now that we have read through the full question and all available answer choices, let's move into the explanation together. To start with, responsible AI practices emphasize minimizing risk and protecting user privacy, which means limiting how long sensitive biometric data is stored. Therefore, option C aligns directly with responsible data governance because keeping facial data only for its stated purpose reduces exposure, lowers misuse risk, and supports privacy by design principles. In contrast, option A introduces unnecessary risk, since indefinite retention increases the chance of data breaches or misuse over time. Similarly, option B is incorrect because encryption protects data in storage, but it does not remove the need for clear retention limits or deletion policies. Finally, option D is misleading because even anonymized biometric data may still require controlled retention, especially in regulated or sensitive environments. As a result, limiting facial data retention strictly to its intended purpose remains the most accurate and responsible approach. Question 53. What is the key functional similarity between DAL-E3 and GPT-Image-1 in Azure AI Foundry? Select one answer. Both generate new images from natural language prompts. B. Both translate text between languages. C. Both provide pre-built image search libraries. D. Both analyze existing images to detect objects. The correct answer is A. Both generate new images from natural language prompts. Now that we have gone through the question and all the answer choices together, let me walk you through the explanation step by step. To begin with, both DAL-E3 and GPT-Image-1 are generative image models, meaning they take descriptive text prompts and transform them into brand new images. This shared capability is the core similarity between the two. As a result, option A is correct because both models interpret natural language and synthesize original visual content based on that description. On the other hand, option B is incorrect, since text translation is handled by language translation services, not image generation models. Similarly, option C does not apply, because neither model searches existing image libraries. They create images from scratch instead. Finally, option D describes computer vision and object detection tasks, which focus on analyzing existing images, not generating new ones. In summary, the defining similarity between DAL-E3 and GPT-Image-1 is their ability to generate new images directly from natural language prompts. Question 54. You've built a new Azure AI Foundry project and want to test image prompts visually before integrating them into your app. You also need to fine-tune how detailed and bright the generated results look. Select one answer. A. Azure Blob Storage Container. B. Azure Machine Learning Workspace. C. Images Playground in Azure AI Foundry Portal. D. Azure Virtual Machine Scale Set. The correct answer is C. Images Playground in Azure AI Foundry Portal. Now that we have gone through the question and all the answer choices together, let me explain why this option is the correct one. To start with, The Images Playground in Azure AI Foundry is specifically designed for experimenting with image prompts. It allows developers to visually test prompts, adjust parameters like image style, brightness, and level of detail, and immediately preview the results. As a result, Option C fits perfectly because it supports rapid experimentation before integrating image generation into an application. By contrast, Azure Blob Storage, Option A, is used for storing data and images, not for generating or testing them. Meanwhile, Option B, Azure Machine Learning Workspace, focuses on training and managing custom machine learning models rather than prompt-based image generation. Finally, Option D, Azure Virtual Machine Scale Set, is a compute scaling service and has no role in testing or generating AI images. In conclusion, when you want to visually test image prompts and fine-tune how results look in Azure AI Foundry, the Images Playground is the correct and intended feature to use. Question 55. A developer is building a form processing application for a financial firm. The forms include standardized W-2s and receipts, and the developer doesn't want to spend time training models. Which component should be used? Select one answer. A, Azure Machine Learning Model. B, wrong. B, Layout Model. Wrong. C, Custom Model. Wrong. D, Pre-built Model. Correct. Now that we have gone through all the answer choices and identified the correct one, let me walk you through the explanation. To start with, pre-built models are specifically designed for common and standardized document types, such as W-2 forms, receipts, and invoices. They work out of the box, meaning no training or labeling is required. In contrast, a custom model would require collecting samples and training the model, which directly contradicts the requirement of saving time. Similarly, a layout model focuses mainly on document structure and OCR, rather than extracting well-known semantic fields from standard financial documents. Meanwhile, Azure machine learning models are general purpose and are not part of Azure Document Intelligence for form processing. As a result, when dealing with standardized forms and a requirement to avoid training, the most efficient and appropriate choice is the pre-built model. Question 56. Arrange the following key stages in the Azure AI search pipeline in the correct order. Connect to data sources. Index data. Enrich data using AI skills. Store enriched insights in a knowledge store. Query the index to retrieve relevant results. Now that we have carefully read through all the stages presented in the question, let's walk through the explanation step by step. To begin with, the Azure AI search pipeline starts by connecting to data sources such as Azure Blob Storage, Cosmos DB, or SQL databases. This step ensures the system can access the raw content that needs to be made searchable. Next, the data is indexed. Indexing organizes and structures the content so it can be efficiently searched later. Once indexing is complete, AI skills are applied to enrich the data. These skills can extract entities, key phrases, translations, or image insights, adding meaningful intelligence to the content. After enrichment, the resulting insights are stored in a knowledge store. This allows the enriched data to be reused for analytics, reporting, or integration with other applications. Finally, users query the index to retrieve relevant results. At this stage, the system leverages both the index structure and the enriched insights to deliver accurate and meaningful search responses. Question 57. What best describes the role of the enrichment pipeline in the Azure AI search indexing process? Select one answer. A, transforms and enriches extracted data through sequential skill applications. Correct. B, defines the index schema for searchable fields. Wrong. C. Stores final index data for queries. Wrong. Acts as the original source of raw documents. Wrong. Now that we have gone through all the answer choices and identified the correct one, let me explain how this works. To begin with, the enrichment pipeline sits between raw data ingestion and indexing. Its primary responsibility is to apply AI skills in sequence, such as OCR, entity recognition, key phrase extraction, or image analysis, to transform and enrich the content. By contrast, defining the index schema happens in the index definition itself, not in the enrichment pipeline. Similarly, storing final index data is the job of the search index, which is queried at runtime. Meanwhile, the original source of raw documents is the data source, such as blob storage or a database, not the enrichment pipeline. Therefore, the enrichment pipeline's core role is to transform and enrich extracted data through sequential skill applications, enabling richer, more intelligent search experiences. Question 58. Fill in the blanks by selecting the correct options from the drop-down menus. Before calling the REST API, provision an Azure AI Services multi-services resource. You can create it directly in the Azure portal or by creating an Azure AI Foundry hub. Now that we've read through the full sentence and identified the correct options, let me walk you through the explanation. To begin with, an Azure AI Services multi-services resource is the foundational requirement before any REST API calls can be made. This resource provides the shared endpoint and authentication needed to access Azure AI capabilities. Next, you have flexibility in how this resource is created. You can provision it directly through the Azure portal, which is the most common and straightforward approach for many developers. Alternatively, creating an Azure AI Foundry hub also provisions the same underlying multi-services resource, while additionally enabling centralized project and model management. As a result, whether you choose the Azure portal or Azure AI Foundry hub, both paths correctly satisfy the prerequisite for calling the REST API. Question 59. For each statement below, indicate whether the answer is true or false. A schema defines the fields an analyzer extracts or generates from content. True. Each field in a schema must specify a type, method, and description. The method value extract means data is inferred rather than read. False. Analyzer creation requests are synchronous and return results immediately. False. Now that we've gone through all the statements and their correct answers, let's move into the explanation. To begin with, a schema plays a foundational role because it defines the structure of the data an analyzer works with. This includes fields that are either extracted directly from content or generated through analysis. Next, each field within that schema must clearly declare its type, the method used to obtain the value, and a description. This ensures the analyzer knows exactly how to process and interpret each piece of data. However, when the method is set to extract, it simply means the data already exists in the document and is read directly. It is not inferred or predicted, which is why that statement is false. Finally, analyzer creation does not happen instantly. The process is asynchronous, meaning the request returns an operation location, and the client must poll until the analyzer is fully created. This is why the final statement is also false. Taken together, these points clarify how schemas and analyzers are defined, processed, and created within the service. Question 60. Which requirement must be configured to allow Azure Document Intelligence Studio to store labeled files in a storage container? Select one answer. A. Cross-origin resource sharing. Correct. B. Virtual network peering. Raw C. Private endpoint. Wrong. D. Access control list. ACL. Wrong. Now that we have gone through all the answer options and clearly identified the correct one, let me explain why this is the case. To start with, Azure Document Intelligence Studio runs as a browser-based tool. When it saves labeled files, it needs permission to write data from the browser directly into an Azure storage container. This is where cross-origin resource sharing, or CORS, becomes essential. CORS explicitly allows browser-based applications hosted on one domain, such as the Studio, to interact with storage resources hosted on another domain. Without CORS, the browser blocks these upload requests. In contrast, virtual network peering only connects virtual networks and does not influence browser upload behavior. Similarly, private endpoints secure network access but do not control cross-origin browser requests. Finally, access control lists manage identity-based permissions, but they do not enable or override browser security rules, which is why they are insufficient on their own. So, configuring CORS is the specific and required step that allows labeled files to be stored successfully from Azure Document Intelligence Studio.